Hello and welcome to this first video to do with organic chemistry. Now, organic chemistry is fantastic. The first question you might ask actually is, what is organic chemistry? And organic chemistry is the branch of chemistry that studies compounds that have a carbon backbone. Now, what you might not realise is that there are more organic compounds than all other types of compound put together, which is phenomenal. I mean, there's millions of them, okay? But because there's so many of them, what we do is we tend to make it easier to understand them by placing them into families, and we call those families their functional group, okay? And the functional group is the part of the molecule that determines the type of chemistry that it undergoes, okay? There's loads of different functional groups. These are just some of them here. The main ones you're going to be studying at GCSE are going to be the alkanes, the alkenes, the alcohols. Depending on your specification as well, you'll have carboxylic acids and esters in there. And there's also going to be a tiny little bit of amides if you're going to be doing some sort of polyamide chemistry, so there's something to do with polymers later on down the lines. You will study more of the others if you carry on into sixth form chemistry, and even more so if you continue on to degree, but those are the ones we're going to concentrate on, particularly at GCSE. You also need to come with a knowledge of the valency of different types of atom from previous units. So you should remember that carbon needs to make 4 bonds, hydrogen wants to make 1 bond, oxygen makes 2, and nitrogen makes 3. There are loads of others, but these are the main ones that we end up using in organic chemistry. There are others, but let's focus just on those. And you should be able to work out the rest. The other thing I would like to point out before we start drawing any form of molecule is that there are both single and multiple bonds that can be drawn. And single bonds are drawn by a single line between 2 different atoms. Okay, it is one shared pair of electrons in a covalent bond. You can have a double bond. Here it's been drawn as a carbon-oxygen double bond, so that would be 2 shared pairs of electrons in a covalent bond. And you can even have here a carbon-nitrogen triple bond. And the type of bond between atoms can actually control the chemistry that it undergoes. Some bonds are stronger than others, some bonds are weaker than others, they're easier to break or harder to break, etc. So that can determine what type of chemistry that it undergoes. So now we're going to move on to ways to represent molecules, okay? And there are different ways of drawing molecules or representing them. We might have something called the empirical formula, and that is the simplest whole number ratio of the atoms in a compound. And that may be different to the molecular formula, which shows the actual number of each type of atom in the compound. And it will always be a multiple of the empirical formula. That multiple might be 1, but it is always a multiple. And then we've got a structural formula, okay? And that shows how the atoms in a molecule are actually joined together. And there's going to be different ways of doing that, and I will show you that in due course. But let's look first of all at the empirical formula and the molecular formula, okay? Well, the empirical formula can be found out experimentally, but it won't always tell you what the molecular formula is, okay? And if you carry on doing chemistry, you will do a unit called quantitative chemistry, and you will be given data where you can work out what the empirical formula is. The molecular formula, as I've already said, is always a multiple of the empirical formula. But neither of them tell you anything about the structure of that molecule. So for example, methane has an empirical formula of CH4, and it happens to have here a molecular formula also of CH4. Ethane has an empirical formula of CH3, but a molecular formula of C2H6. and then there's a molecule called ethanoic acid, and the empirical formula for ethanoic acid, also vinegar by the way, is CH2O. But the molecular formula looks very different. It's C2H4O2. So it's always a multiple, even if that multiple is 1. But from that information, I wouldn't be able to draw what the structure is of ethanoic acid, what atoms are bonded to what. And to be able to do that, I need to know something about the structural formula. Okay, and there is something called the displayed formula. Okay. Now, the displayed formula shows how the individual atoms are bonded within a molecule. And we draw lines between the atoms according to whether they are single bonds or double bonds. For example, here we've got propanol, or propan-1-ol, and we'll get onto the naming of it in a later video. And here we can see that we've got carbon-carbon single bonds. We've got carbon-hydrogen single bonds. We've got an oxygen-hydrogen single bond, and we've even got a carbon-oxygen single bond there as well. So we've got quite a few of those. Okay, and that shows us how it's actually bonded together. There's also a slightly condensed form of this, where we take each portion of our carbon backbone and we condense it down. So this CH3 unit becomes just a CH3. We have a CH2 next, which becomes this CH2. There's another CH2 here, which becomes there, and then we've got our OH, which goes at the end separately, and that tells us the logical order from left to right of how it is arranged. There is something also called the skeletal formula, and these come in handy when the molecules get really big and it's really difficult to fit everything around it. Because the skeletal formula is actually a simplified version of the displayed structure. You don't draw hydrogens on carbons, but you do draw hydrogens on any other atom. You also don't actually label the carbons, okay? And when you draw the lines, at the end of each line, you assume that it is carbon. So here, for example, we would assume that is carbon, we would assume that is carbon, and we would assume that is carbon. We would also assume that if that is carbon here, then it must have 3 hydrogens, because it wants to have 4 bonds. We've got 1 bond here, but it wants to have another 3, and we just assume that it's this. But we've simplified it so we don't have to draw it. Okay. Now, I think that makes it a lot easier, especially when it comes to drawing large molecules. Okay, and this is exactly the same as the molecule we've had on the previous slide, propan-1-ol. There are different ways, though, of representing molecules. There's a ball and stick model, and there is something called a space fill model. Now, if we're looking at our propan-1-ol, then our ball and stick model just shows you a representation of rough lengths of bonds with balls as the atoms and sticks as the bonds. And then the space fill model tries to give you the approximate size of each of the atoms and how actually they're all roughly fitted in space, but it can get a little bit difficult to see. So I hope you've enjoyed this video as the first one on your journey into organic chemistry, and I hope you continue watching. Thank you and goodbye.